Simone will talk about Jetty 12, and we are very happy to have you here. javaBin is the Norwegian Java user group. We have local branches all over the country. We do a lot of meetups in the different cities in Norway. So that was my short introduction. We will talk about Jetty today, and I will just hand the word over to you, Simon. So here you go.
Thank you, Darish. Sun is fine, looks like, so let's start. Okay, so my presentation is about Jetty 12, and who am I? I am a Java champion. I work for the company that provides services and support for the Jetty project, and also for another Jetty project called CommonD. It's a library that performs web messaging, so you can do server-side events delivered to browsers. And this is useful, for example, for games, online games, or monitoring consoles, or anything that happens on the server side and you want it to be delivered on clients. But I'm here today to talk mostly about Jetty. It's going to be something more about Jetty, more about technology in general, related to the Java world. So if you have any questions, just ask, then I'll answer. So Jetty is a very old open source project. It's probably one of the oldest, if not the oldest, still alive and active. It was born in 1995 because Greg Wilkins at the time, the founder of the Jetty project, was entered the competition that was put up by Sun Microsystems for this new language that Sun was developing called Java, and they wanted someone to write a cool project about using this Java language. And so Greg decided to write a issue tracking system but on the web. And in order to write the issue tracking system, we needed a web server because at the time there were no web servers in Java because the language was so new. And so basically we wrote the web server first, and then over the years this has been evolved and became what it is today. Over the years, we've been innovating on many fronts, especially when in Java 1.4, non-blocking I/O became part of the JDK. Jetty was one of the first, if not the first server to actually use those API to make the server non-blocking. On top of that, we had a library called Jetty Continuations, which was used for many interesting use cases that at the time were not available at all. And eventually, the Jetty continuation concept was standardized and became what is now the Servlet 3.0 async servlets. So the fact that today you can do request to start async and start an asynchronous processing of a servlet, it is due to the fact that we have introduced the Jetty continuation first using the NIO, and then this became the standard. Also was the first server to implement WebSocket when the protocol came out. It was the first to implement Spoody, which was the antecedent protocol of HTTP2, and now it's called HTTP2. We also implemented HTTP3 a little later with respect to others because HTTP3 is way more difficult to implement in Java, especially for the lower layer called Quick. But eventually we led the path for innovation on many of these technologies. And lately, we are also the first and the only, so far, server to support multiple Jakarta EE environments in the same server. We'll see more details about this in the next slide. So, in reality, Jetty is, maybe lesser known than other containers, such as Tomcat or something like that, but it powers a lot of big companies. So, for example, if right now you're going to deploy something on the Google Cloud Platform, and it's in Java, you're going to deploy it in Jetty. And so Jetty powers fundamentally Google App Engine and the new web function things. And every application that runs in their environment, these environments, obviously is powered by Jetty. For example, Snapchat is one such example. It is written in Java. It's a web application. It runs on the Google Engine platform and runs by Jetty. The whole backend of Salesforce runs on Jetty. LinkedIn used to have services that run on Jetty. The whole Cisco, Facebook, American Express, the list is really long, but the big ones are all there. And we integrate with many projects. Over the years, Spring, we have integration with Spring and Spring Boot, but then javaBin, it's a Kotlin-based project that also uses Jetty for its API and the availability. And the fact that it's very easy to embed Jetty in a normal Java application. Drop Wizard, Gerrit is the source control system related to GitHub, which helps with reviews and everything. And if you go and look at the GitHub statistics, we have 40K plus projects that depends on the Jetty Servlet library, for example. And so many people choose Jetty because it's open source, has a friendly license, but especially because there's a company behind it that supports the project. So if you use Jetty and then you have a problem, well, then there's a company behind, or you are a big company and say, okay, I want to bet on this product because I think it's good. Well, but there is a company behind it that supports me if there is anything that goes wrong, or if I have to do, for example, I chose Jetty in the past, but I didn't ask for support. And now I have an old version of Jetty and I would like to move to Jetty 12. Should I invest 20 engineers of my own company to do the migration over that? Or maybe that money is better spent into having a contract with our company, which we can do the job much faster or help you to do the job much faster. And then we just use the 20 engineers for your stuff, not for infrastructure stuff. But also for the features, we're fast and scalable, flexible. We support WebSocket, HTTP2, HTTP3. We are full JPMS compliant, so you can actually J-link Jetty and your application and create a small executable. Then you can copy around and deliver whatever you want. We're always innovating, and the real goal is that we're not really pushing standards. Like, we're not telling you we are a standard application server. The only thing that we support is if you create a wall and deploy it to us and etc. We also support the fact that you use directly the Jetty API because maybe it's more flexible, it gives you more performance, or it gives you more flexibility that you do not have with the standard, and so you can do more stuff. The goal is to fundamentally give you a solution for the web, the HTTP in general, but any web protocol, and not to push some kind of technology. But of course, we also support Jakarta EE at the fullest. And we're not only a server, we have all the client libraries as well that go with the server side. So we have an HTTP1 client, but also HTTP2, HTTP3. We have the high-level client that you can make a request and say, I want to get this resource. But then how that get this resource gets translated into network bytes, that depends on the specific protocol that you want to use. And so you can have, maybe you're not worried about what protocol you use. You want to just contact a server. If the server says, I'm speaking the HTTP2, for you, should be totally transparent. And this is what you can do with our client. Or you can say, well, no, I exactly want to go the very low level because I really want to speak HTTP2 frame by frame because I know that I have to do some special things. And so you can do that too because we have also the implementation of the low-level client. Obviously, when you have a server and a client, it's perfect for microservices because then you can just arrive on a microservice, call all the others, and then gather all the results from all the microservices and then produce a response to the remote client. So, yes.
You need to share your slides.
I need to share my slides. Okay, let's do that. That's a good one because otherwise. Okay, let's go for this one and this one. Good. Okay. So let's talk about Jetty 12 specifically. So what happened was the following: is that the Java EE Enterprise API were at Oracle, but then they moved it to Eclipse, and that move lasted for like years because of legal issues and everything. And so now we have Eclipse where Jakarta EE, they still have the old JavaX.Servlet something classes, but then there's the new Jakarta EE9 that is now the Jakarta.Servlet something, but the two classes are different. So many people were blocked by this because they said, oh, we have like, for example, 20, 30, 50 applications written against the JavaX API, and now we need to do a big effort to move all of them into Jakarta EE, and maybe it didn't work, and maybe, I have to take a bunch of people, put them to do all the translation, and it's complicated. And so they were scared by that, and this was legit, and but it was not really, it is not really the case because the translation is literally can be automated by a tool. In fact, Tomcat is a tool that does that. We have the implementation that we have inside Jetty for EE8 is a translation, a mechanical translation of the code for EE9 back into EE8 just by changing Jakarta.something with JavaX.something. Of course, the conversion is a little bit more complicated and nuanced. There are strings around that still have JavaX in it that should be converted to Jakarta something, which are maybe in line by the compiler, so they are present in the bytecode as JavaX, and they need to be converted into Jakarta. So, it requires a little bit of attention, but it's not particularly complicated. But I can understand the project manager to say, for 50 applications, this will take us 1 year to do the job, right? But eventually, this is where the Jakarta EE standard goes. It will eventually move along and become EE10, which is now, and then become EE11, which is going to be the next one released in the summer. Also, the other thing that changed is that with the introduction of the Server 6.0 in Jakarta EE10, some of the methods that were deprecated for years and years because the Servlet API were one of the first standards that was ever produced, I think back in the late 90s even, started removing methods that were deprecated. And so now if you try to deploy a web application that is written against Servlet EE, Jakarta EE9 into a Servlet 6.0 EE10 application server, if that application uses some of the methods that are now removed, well, it doesn't work anymore at runtime, right? So now you have a problem, and it's going to be complicated. And so what it means what? That if you have your 50 web application and you start saying, oh, but the 51st web application is going to be written with the new standard, now you need a web server for all the old ones, but a new server for the new ones. And now you have to manage two servers rather than just one, which maybe you had before. You have to, maybe the versioning of the two servers is not in sync, and so now you have, a bunch of other problems to do. So there's other behavioral changes that change the Server 6.0, so that's not really, you really need two different servers for your new web applications. And so for us at the Jetty project, what was the problem? The problem is that if we wanted to maintain different standards along, we needed to maintain different versions of Jetty, but then that meant that we basically needed to maintain 4 versions of Jetty, alive at any time. And so we decided, so for example, Tomcat has chosen this path. So if you want to deploy EE9 application, you go for Tomcat 10. If you want to deploy EE10 application, then you go for Tomcat 11. And you cannot just take Tomcat 11 and say, oh, everything goes there because it's backward compatible. It's not anymore. So what we have done with the Jetty project was, we sit around the table and we say, okay, how do we solve this problem? Well, the solution was for us to make a core engine in Jetty that was completely independent of the Jakarta APIs, and then on top of that engine, build the specific implementation for each different version of Jakarta EE. So EE8, EE9, EE10, EE11, and then in the future moving forward from that. And so with Jetty 12, now what we can do is that we can deploy E8 application, E9 application, E10 application, and then 11, and 12, and whatever, inside the same server. And not only that, but the fact that we now have a core engine API that is Jetty specific allows you to fundamentally write web applications exactly very similar to the web applications that you had with servlets and everything. But now they're Jetty specific, and you can deploy them alongside with Jakarta ones. And the benefit of doing that is that you're going to have a performance boost of about 15%. And this is because we don't have to do all the things that the server specification requires us to do. And so this overhead goes away. And the counterbalance of that is that obviously you're not coding anymore against the standard, but you're now coding against the Jetty specific API. So now you're Jetty specific. Okay. However, the API is simpler than the standard one, and it works, as well, even better performance-wise. For example, we have bragged about this, and we have the daily performance tests that we run every day over continuous integration. Through this link, you see, for example, we run a single Jetty server with 4 clients, and we just bombed the server. And I think for this setup, or with the new setup, because we bought new machines, we're now bombing the server at 480,000 requests per second with 4 clients. And so Jetty just runs fine with that, and we can just go on. So it's a good number, which makes removes completely from the table that Jetty is a fast server. Yes, we can do almost 500K. Well, we certainly can do 500K requests per second because we do 480, and so we just need to push a little bit more with the clients. But the problem with the performance testing is that typically it is the client that has problems. Up to a certain number of requests per second. So we will need more machines on the client side in order to make the server even bike as well. So this solution for Jetty that we have is perfect if you want to transition old applications, E8, that you do not want to change because, for example, that's the typical Crystal application that nobody touches that application because it's the application that runs our whole system. All the people that wrote that application just went away, and nobody knows how it works, but it works, and so nobody touches it. You can just take it, put it into Jetty 12 rather than Jetty 9 or whatever it was before, Tomp or whatever. And but the new application can still be deployed on the same server if you so choose to do that. And so that will fundamentally create a perfect environment to transition old applications to new application. And the benefit that you have is that now you have a modern server, because now you have a server which is not anymore Jetty 9, you're now Jetty 12, you are forced to use Java 17, but we also have support for virtual threads, which we'll talk a little bit about later, but you have the latest security and vulnerability patches and everything. So the new development, the new performance that we can improve and all the features that we add, etc., will be on the latest version of Jetty, and so that will be the modern server for you as well, even if you're running all the web applications. We also support cross-context dispatch. I don't know if you're familiar with this, but with this Jakarta API, what you could do, you could say, I am inside one web application, okay? And typically the developer does not know on what context this web application is deployed. For example, /foo or /bar, right? You don't know. Because typically when you write the application, the only URI part that you're interested in is whatever is after the context path, right? The context path is not really interesting to you. It's like, I want to deploy a servlet at this place or at this URI, at this other URI, but these always come after the context path. But what you could do, you could say from one web application to say, hey, this request is not for me. I want to forward this request to a different web application on context /bar, for example. This was not really a great idea or whatever, but now what we can do is that we can take a request coming into the server as JavaX request, and then do a cross-context dispatch to a different web application that is written against the Jakarta Servlet API, and then we'll just do the magic to have this application be web application to receive this request as if it was directly arriving there from the client, right? And so this was not simple, but we managed to do it, and it's there. Because of course we said at the very beginning, nobody's using this feature, come on, until you arrive at one of your clients, like the ones that pays us for support, that says, hey, they will do cross-context dispatch. Is it functioning? And we say, well, no. How do you do a cross-context dispatch? Oh, no, we have old applications that dispatch to new application, and now it's so different. So, but we have implemented it. So, because of course clients always have their own reason, and they must be pleased. So the other thing is that we integrate nicely with Spring, and Spring 6.1 and Spring Boot 3.2. But the integration currently, how it's done in Spring, is done through the Jakarta API. So what happens is that you write your application against the Spring API, and then the Spring API convert the Spring API into Jakarta API, and then Jakarta API goes into either Jetty or Tomcat, okay? And that works fine. Of course, however, in this case, you're still going through the Jakarta layer, and that is slightly less efficient than trying to go directly to the Jetty layer. So if you like Jetty and you want your integration with Spring via Jetty, then what we have done is that we have set up a pull request to the Jetty project to say, hey, when people write web application and they want to use Jetty, what we can do is that people write application against Spring, but rather than going through Jakarta, we go straight to the Jetty core API. And from there, you get the 15% performance bonus that I was talking about before. So this is now being reviewed, and it will be integrated into the Spring project. So how do we use Jetty as a standalone server? What we have done with Jetty is the following. We have basically split every functionality of the Jetty server into a Jetty module. And when you download Jetty, you download all the core engine that runs the Jetty server, but then all these modules are just there, but they're not enabled by default. So this is very similar to what you're going to do with Apache modules, for example. You need to enable them if you want that functionality. And the same happens for Jetty. So you download just the core engine, and then you can have all the modules, and then you just select, okay, I want to, in this particular server configuration, what I want is support for only HTTP1, for example, and only clear text. I don't care. Or you have another configuration where you can say, no, in this other configuration, I have other web applications where I want to have support for HTTP3, HTTP2, and HTTP1, and maybe even FastCGI, and maybe even other things, right? So what we have done is that we have split the actual jars into that you can install in your system into a place called that we call Jetty Home. And so there are the jars that we download from the Jetty distribution. Every time there is a new Jetty version, you just update those files, and that's it. Then your configurations are in a different place that we call Jetty Base. And there is where you say, okay, in this particular Jetty Base directory, I want to have only the HTTP1 clear text support, and that's it. Or in this other directory, different Jetty Base, I want to have HTTP2 and HTTP3 and HTTP1 support. And so this is how you do it, super simple. You just prepare the Jetty Home, you just download the Jetty Home with the version, you just unzip it and into OPT, for example, /OPT, and that's where it stays there. And then you create a Jetty Base into a different directory, like user local. And then you do your Jetty Base, and then you cd into that, and then you say, okay, I want to add module, just the HTTP module, and that's it. Okay. And that will create a Jetty server that is able to understand the HTTP1 protocol. And then we just start Jetty, and then it will just reply. So this is super simple, and what this Jetty server will do will basically receive an HTTP 1.1 request, but because there are no web application deployed to it, it will just reply, I don't know what to do with this request. This is a 4.4, right? It's not found, whatever you ask me. I understand you, but I have no web application deployed to me, so I don't know how to treat this request. For example, we can add additional modules. Here we can add HTTP2, deploy, JNX. So HTTP2 is, of course, the protocol support for the protocol. Deploy is support for hot deploy. So now you can drop a WAR file into the web apps directory, and that will deploy your web application. JNX is the support for JNX, so you can connect to the Jetty server through a JNX console, and you can see things that what's going on inside, and so other things like that. And you can do this. For example, this could be a different configuration in a different base directory. So, for example, in this other base directory, base 2, you're going to have support for HBS, the FastCGI, and deploy. So, for example, FastCGI is the support that we have in FastCGI and Jetty is exactly the same as you have in Nginx or Apache. Browser makes a request, the server converts that request into FastCGI and then gives it to, for example, a PHP. So our own website is now served exactly in this way. We have WordPress on the back end, but it's not served or called by Nginx or Apache in the front. It's called by Jetty. So Jetty receives a request from the browser, calls the PHP engine of WordPress. WordPress generates the HTML page, all the way goes back to the browser, and you see the website on your browser page. Every module adds a configuration file, because of course you want to configure things, right? So for example, the HP module creates this hp.ini file where it says, okay, the module that I want to enable is the HP one, and then the Jetty HTTP port is by default, you see this line is commented out, is the 8080 port, okay? And if you want to change that, you have two ways. Either you specify the property on the command line, but that will only work when you start Jetty and then you leave it up, right? Then if you kill that particular thing and then you start and forget to add the command line option, then it will start again in the 8080 because it's the default. Or you can change the INI file to make your configuration persistent. And you just uncomment the line, you change the port to be 9090, and Jetty on every restart will start with the new configuration. So this is for example, an obsolete setup that now we don't recommend anymore. Like it has the browser talking HTTP1 to Apache, the web server, then talking to a very old AJP or HTTP protocol to the backend Tomcat or Jetty, whatever. What we suggest now, it's modern stuff, is the browser talking to HTTP, which is a fast and efficient proxy. The browser can talk HP1, HP2, and HP3 to the proxy, as well as it could with Apache, right? Now, I don't know Apache and HP3. I don't know if it is supported, but HTTP certainly does. And so HTTP also has a very efficient TLS offloading library, so it can decrypt everything for you. And then it can just call the backend. And the backend could be Jetty. And right now, the backend can be called in HP1 and HP2, clear text, but not yet with HP3. But there's an asterisk here because we're working on yet another innovation, which is still in super draft mode, etc. But it's modification of the quick relay level protocol that will allow us in a way simpler way to basically talk to the backend, but not via UDP, but via TCP. So this is called Quick on Streams. We're working on it. We think it has potential, so it's going to be interesting for the future. Okay, so that was about the standalone server, right? So you download the jars, the zip, you install the zip somewhere, you drop your web application into the web apps directory, start the server, it runs. Or you can use the Jetty libraries embedded in your application. So you can just write a main class and just use the Jetty library embedded. Here's 2 lines to start the Jetty server on port 8080. And again, what this does is absolutely nothing. It just replies 4 to every request. But you can add what we call Jetty handlers to create different behaviors and drive your own web application. So, for example, this is how you would do it with the Jetty Core API. You first create what is called a context handler, which represents a web application. And you say, okay, my context path is /app. And then you say, okay, now there's a server which will call the context handler because it's a web app, right? The context handler will say, hi, I know that I have to reply to every request that comes to me that starts with /app. If it does not start with that, then it's not for me. Okay, so that's the role of this guy. Okay, but once you know that the request starts with app, what exactly do you do, right? Okay, so then you add a child to the context handler, which implements your own logic. And so this is now an handler abstract, and you have a method called handle, which takes a request and response and a callback. The request and response are very similar to the Jakarta request and response. The callback is there because in Jetty, everything is asynchronous. And so we allow you to be a lot more efficient by doing that, and we have the callback. Now, the question becomes, do we go into callback hell, right, which is the typical JavaScript problem into the callback hell? The answer is a little bit, but not too much. We have tried to make the API very friendly and avoid as much as possible the callback hell. Still, it is a problem. The callback hell it's natural if you're going to do asynchronous programming. There's a little bit that you can do. You can trade callback hell for more allocation, and then you lose a little bit in performance, but maybe the code looks a little bit better. But at a certain point, you have to give somewhere, right? But the good benefit that you have is that you have, much better performance in general. So the API works in a way where you receive a request and response, you have to do whatever you need to do, and then the contract is that you have to return a boolean. The boolean says, yes, the request was for me, I am handling this request. But maybe in a moment, not now, right? But the contract would be that if you return true immediately, then you will complete this callback that you've given, right? So you can say, for example, okay, I received a request, but in order to fulfill this request, I need to call on asynchronously a third-party web service somewhere. And it will take time for that web service to give me back the response, okay? Meanwhile, I know that this request is for me. I already set up the call to the external service. I'm going to conclude this request. Don't worry, return true. Then eventually, you get the response from the third-party service. You figure it out, you process it, and then you produce a response, and then you say, okay, write back what you requested. And then when you're done, you just callback succeeded, the request is now finished. But this can be completely asynchronous. All right, so the API is fairly intuitive. Of course, benefits, less overhead, better performance, better footprint, footing and blocking, all the goodness. It's there. This is the same example, but written with the Jakarta EE Servlet API, but with no class loader isolation. So it's a mix of things, right? Now, what we want to do is, for example, you've written your servlet with your complex logic in there and say, okay, but I want to reuse this servlet. I don't want to convert it to a Jetty handler. I want to just continue using this servlet, right? So what you can do is now you just create a servlet context handler, as we did before with the normal context handler, and then you just servlet to it, and you say, hey, this servlet is responding to this path mapping. And that's it. Now you have your servlet deployed into this thing. The jar containing your servlet and the jar containing the Jetty implementation will be in the class path, in the same class path all together. Okay, and this is a very simple way of deploying things because you don't have to worry packaging into a Word file, creating a web.xml, whatever. You just have your servlet. You say, well, this is the jar with the servlet. Put everything together in the class path, run it. It works. And the last, of course, the last version of it is that now you have full Jakarta EE10 with cluster level isolation. Now you have not anymore a reusable serverless somewhere, but you have a full WAR developed by some other department of your company that gives you the whole WAR file. And at that point, you just say, well, now we have a web app context that we attach to the Jetty server. And this is the path to the WAR file that you want to deploy. And that's it. You just start the server. So you have full flexibility depending on what is it that you want to do. You can just task your developer to say, don't worry about the web.xml, don't worry about dependencies, whatever. We'll manage all the dependencies for you. Just write the servlet, give me the jar with the servlet, everything is taken care of. And we'll deploy into Jetty and it will work. Even though we have our own API, we're still strongly committed to Jakarta EE. It's going to be that if Jakarta EE 11 is coming out, we are going to implement it. If Jakarta 12 is coming out, we are going to implement it and make Jetty top-notch Jakarta implementation. And we're trying to still be very good friends with all the other frameworks that will use Jetty as their own base for integration with things. As I said, John, Wizard, and many others. This is a snippet of XML. It's the full thing, actually, to what is it that you need to do to go into Spring Boot, and which by default uses Tomcat, and tell Spring Boot to use Jetty instead. So what you have to do here, you have to say, well, first of all, you want to depend on Spring Boot started Jetty here. And then what you need to do, you need to exclude Tomcat and say, hey, for the starter web, exclude the dependency of Tomcat because it's automatic. And so you need to explicitly exclude it, but it will be replaced by the Jetty one. And that's it. When you do this, your Spring Boot web application will just start on Jetty transparently. So that's good. The other thing that we support in Jetty is virtual threads. So let me just do a quick poll here in the room. How many have already used virtual threads? What? Cool. You know about virtual threads? Okay. Yep. So virtual threads are the new cool thing, and we support them in Jetty. It's the support, however, it's tricky in a way. We'll go a little bit into details about this, but we have three modes fundamentally. One is no virtual threads. We just use the platform thread as usual. And the second mode is we have a mixed way of using virtual thread, meaning that we use platform threads for everything that Jetty does. So especially the I/O layer is done by Jetty, by platform threads. But then we call the applications, so servlets, server filters or Jetty handlers, whatever you have written, is being called with a virtual threads. And so this is useful because the good stuff about the virtual threads is that they give you this transparency that when a thread blocks, the virtual threads goes away, and then the carrier of that virtual thread can do something else, right? And this is fundamentally getting the asynchronous benefits into a blocking web application that we have written, but with the simplicity of continuing to use the blocking API, and because transparently the JVM will take care of the scalability for you. So that's really good. The third mode that we have is that everything is a virtual thread. And unfortunately, the everything is a virtual thread, it comes with a little bit of, it must come with a little bit of knowledge in the sense that the things that Jetty does at the NIO level are pinning a virtual thread. And pinning a virtual thread is the worst possible thing that can possibly happen currently in the platform. Because what happens is that when you pin a virtual thread, it's like blocking a platform thread. At a certain point, you're going to run out of carriers for virtual threads, right? And so the whole system gets completely blocked. But before you had the choice of saying, well, I'm going to limit my system to, let's say, 200 virtual threads, right? But the whole system could create 201 virtual threads. It's just that it didn't do it because you said no more than 200. Okay, and then the operative system would just juggling all the threads and say, well, if I have 200 or 201, it doesn't really matter. I'm just juggling as before. Easy. With virtual threads, the problem is that if you block all the carriers, then now we run into a big problem because now there are no more carriers available to run virtual threads, and at that point there's nothing that you can do. You cannot allocate one more carrier if you just exhaust all of them. And at that point the system is completely locked up and it just stops working at all. So this is warning. Virtual threads ahead, because everybody thinks, oh, virtual thread is the best of things after a slice of pizza, but it's you gotta know what you're working with. It's not particularly, it's a technology, it's a good technology, but it's a tool. You have to know how it works and what is it that entails using it. So, for example, in the Java code, in the JDK code, it is hard-coded that the max number of carriers that you can possibly have is 256 by default. You can change this value with the system property, but by default is 256. Unfortunately, it has been, the virtual threads have been sold to, you just create how many do you like? You want 1 million virtual threads? No problem, just create 1 million virtual threads. The problem is that if 256 of them pin the carrier and block, well, then you cannot create 1 million of them because the other ones will be there sitting in a queue and nobody will wake them up ever. So you got to be careful of what you're doing. You need to know the system property. You need to know, what am I doing? Is there any possibility that this is happening at all? So much so that, for example, this issue here has been filed against the Jetty project, but it was actually a problem in the Kotlin name library because they were using synchronize to all user code. And so they were just using the synchronized block with a virtual thread that pings the main carrier. And it just so happened that for that particular application, they were pinging all of them. And then eventually the whole system locked up. And they filed the bug to us and say, hey, Jetty doesn't work. And say, wait a second. It's not really Jetty. This is a bad interaction with many things at play, right? There's virtual threads, there's Kotlin with their library, and then there's Jetty also, but there's multiple things. The other question.
Can you just say something really short about why do some libraries have pin threads?
Yes. So the question is why some library pins threads? Yes. So one of the things that is going to be, by the way, solved in Java 23, they're working at solving Java 23, is the following, is that the synchronized block for virtual threads is in the carrier. Okay, so if you have a library of any kind that is using synchronize and then inside synchronize does object wait, okay, that library is not really virtual thread friendly. Okay, and so it might be just a library that was written a few years ago when virtual threads were nothing. I'll give you an example. Typical case is connection pools towards the database. Okay, so what do you do with a connection pool? You say, hey, you configure the connection pool to a database. You will have 50 connections open max to a database. Okay, what do you do if you need 51? When what do you do is typically, okay, the thread is coming in, is looking for one more connection. I do not have any, no problem, synchronize, object wait here until someone comes back, and then I'll wake you up, okay? Now imagine a situation where someone manages to make here 50 connections to the database, perform a query that lasts maybe a long time. And at the same time, you have a spike of load that goes to the database. And so you have 300 concurrent requests arriving at the same time for connection pool, right? At that point, what happens is that you have 300 threads into object wait. And then you have 50 of them still doing the query towards the database, right? So at that point, the whole system is now completely locked up. There's nothing that you can do in there, and you're gonna stay there for a while. When one of the queries returns, it will wake up one of the carriers that says, okay, well, now you can go in, but you don't know what's going on outside. I mean, we're assuming that if you're going to have 300 requests in this second, maybe you have 300 requests per second. So every second you have 300 requests that are going to pile up and pile up and pile up because the queries towards the database take more than 1 second. So you're going to pile up requests onto here until everything explodes from that. And this is also because virtual threads have this property, or not a property, or a feature, but not a feature, depending on how you call it. So why was this not happening before? Because at the front of your system, you typically had a thread pool that said, hey, no more than 200 threads coming here, right? If you did not have a thread that was accepting connection on the IO level, at the IO level, what was happening? Then you had a spike load, and on the browser you will see, oh, cannot connect to the site. Okay, so you had better experience on the browser, but the server was safe in a way that you were not bringing the server down. It was working for pretty much everybody else, but not for you. You were the unlucky one that was seeing that. With virtual threads, you don't have this limit anymore because now you have no pool that limits your virtual threads to 200. So now every time a request comes in, you just say, hey, new virtual thread, in. No problem. New virtual thread, go in. No problem. Enter, 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 enter. And so basically your system becomes completely unlimited. So this is what we see in the next 2 slides from now. I'll go back to this. So what is the other problem that virtual threads introduce is that they trash thread local caches. So again, to go back to your example of the libraries, right? There are libraries that now need to be virtual threads friendly because what they were doing before was the following. They were saying, oh, I have to do an expensive calculation. I'm going to use a thread local and put the results of this expensive calculation into a thread local, with the hope that the outside system would a thread enters, I do the expensive calculation, I save the results into a thread local, I do my stuff, and I return all the way back, right? And then why did I save my stuff into the thread local? Because the hope is that the external system will then take that thread and reuse it later to call again your library. And so in your library, you get the same thread coming back in. You look at the thread local and say, hey, I don't have to do every job. I've already done it previously. I just reuse the results and I just do my work really fast now. Okay, because libraries were relying on the fact that you had a limited amount of threads outside that were reused. Okay, so now what happens with virtual threads? They come in, you do the expensive calculation, you do your stuff, you come back, and then the virtual thread goes out and never comes back anymore. Never, right? And so now you're coming again with a new virtual thread. You have to renew the calculation and be expensive again. And so every single request now becomes expensive. So imagine if you have a system based on this, and you compare a platform thread-only system with a virtual thread one, you would say, oh, but the platform thread one is a little bit slow, is as slow as the virtual threads one for the first maybe 200 requests, but then once you have all the thread locals filled up, well, then this is much faster, the platform one, because it doesn't have to do all the calculation ever again, right? And so you say, oh, virtual threads are stuck. Well, that's not exactly the size, right? They do not suck, they just work slightly differently. So what we have done in Jetty was to replace thread local caches that we have inside, because we use the same trick as well, with something different called a thread ID pool. how does it work? We just we say, okay, we cache, let's say, 10 expensive calculations, okay? And we put it into an array of 10 items. Then the thread that comes in, we take the thread ID and we do modulo 10. Okay, so it happens to be virtual thread number 1, fine. So we go to slot number 1, we do the calculation, we set it there. Then comes thread number 2, 3, 4. Then comes virtual thread number 11. And we say modulo 10, oh, look at that, it's again slot number 1. So we go there and now we find that there is the calculation already there. What if thread 21 and 31 arrive at the same time? Well, one of them will go to the slot, will take out the calculation, which may not be thread safe because it was not supposed to be thread safe. It was in a thread local. And now, so we pull it out, and then so 21 gets it, for example. 31 will look at the slot number 1 and say, oh, there's nothing there. Sorry, I have to redo the calculation. So we do the calculation, put its slot there again. And then when 21 is done and wants to put it back, we'll say, oh, well, okay, I'm going to discard this one because it's already the new one. So there is a little bit of thrashing, but much less than it was with the normal virtual thread. So this is what we've been doing in Jetty. We became virtual thread friendly in the sense that we have removed all the synchronized block. We have removed all the thread local caches so that if you use Jetty virtual threads, you're going to have a good experience. This is what I was saying before. With virtual threads, you basically have unlimited, you're open now to unlimited load, because before the thread pool was pooling threads, but not only, was doing also another job. It was acting as a resource limiter, okay? But now, with virtual threads, that limit is gone. You don't have it anymore. So much so that the current solution that is proposed around is to do what? To use a semaphore in front of your system. So basically, you're putting back the resource limiter in the form of a semaphore. So at the front, you say, hey, virtual thread, no problem, go on. But then as you have a virtual thread, you hit the semaphore. A semaphore is virtual thread friendly. It will park momentarily the virtual thread, but it will not ping the carrier, which is the important bit. And then we will say, okay, from the semaphore down, I know that my system now runs with only at most 200 concurrent requests. And so I can keep my system under control. I can hit the database but not overload the database. I can, hit the file system but not overload the file system, or external system that I call that could be slower than me, right? So I don't want to overwhelm them with too many requests, right? What is the problem with this is that fundamentally we're going back to the previous solution of a platform thread, so they're now kind of equivalent. And if this semaphore is implemented by you, the difference was the following, that if Jetty was using the thread pool, it was saying, hey, I see that someone is connecting to me, but I have no threads available. You know what I'm doing? I'm just wrapping the socket into a runnable and put it aside into a queue in the thread pool. So I was doing very little work, just wrapping with the runnable, put it in the side. Now, if you have a virtual thread that comes, if someone connects, you have a virtual thread that says, no problem, new virtual thread gone. What we're doing now, we are allocating the buffer, reading from the network, creating the request object, creating the response object, creating the callback, creating everything that is necessary, then entering the system until we arrive to the semaphore that you have written, and there now you stop. Okay, but you stop not only the thread, you stop, but now you have the request object with the buffer, with the response object. Now you have a lot of memory that has been allocated in order to arrive to your semaphore that now gives to the system more memory pressure, because now you have to use more memory. So what we will do probably in the near future will be to have, and this is like an oxymoron, and I'll say it now, but for the first time, but a virtual thread pool, but not for pooling the threads, but only for the semaphore, right? Because we want to be sure that we want to be able to create a virtual thread, but only if the semaphore allows us to proceed, right? That is the key trick, because at that point, we can go back and say, hey, it's not about putting virtual threads here, it's about resource linking them. And what we want to do is want to be able, like we did before, to say, hey, there's a new connection, no problem, I'm allocating a virtual thread, but I can't. Listen, I'm dropping this into a runnable, put it inside. Whenever there's going to be a semaphore permit available, I'm going to pull up that guy, attach it to a virtual thread, and let it in. Okay. So we'll see. It's still under discussion, but we'll see where it goes. But yeah. The last thing about virtual thread, what is it? It's that they're really difficult to troubleshoot. And right now, it's really, really difficult. I'll give you like an example, okay? So let's assume you have a system, and then you have a bunch of threads entering into your system, and then for some reason, all of them are hit a lock, proper lock, so very virtual thread friendly, and hit the lock, and then the virtual thread gets suspended. Okay, what is it? The carrier goes back into the main pool. So now you arrive. Let's assume you have a JDBC connection pool at the backend, right? So now you see 300 of them entered, but only 50 of them are actually making a JDBC query to the database. Okay, so now at that particular point, all the queries to the database last, let's say, 10 seconds. I'm just exaggerating for the sake of the example. Okay, so in that moment, you take a snapshot of your system. You go on the JVM and you just do thread dump here. What do you see? You see 50 threads busy waiting for the database to return, because they're blocked into JDBC calls in there. And then you see a bunch of carrier threads idle in the thread pool. But in reality, you have 300 requests at that moment that are waiting, but you don't see them. So you look at the system and you see, well, this system is doing nothing. Where is the 300 requests that are, well, the other 250? I don't see them. You don't see them. You have no way to see them at all. So this is, when you have a client that says, hey, my system is completely locked up and I have no idea why it doesn't advance, then you ask the user, well, just go to the JVM and take a JVM dump. You get the JVM dump and say, well, your system is doing absolutely nothing. So now you have to use other commands like jcommand to see whether there are virtual threads that are actually piling up, waiting for something else to happen, right? And so you can have a hint of your system. Well, I see that there are 50 threads that are building to the database. What is again the configuration for the connection pool of the database? Oh, it's 50. Oh, so all of them are now busy there. So there could be others that may be waiting on that. But it's a multiple step process that will, you need to know the system really well. So what we're doing with Jetty is that if you use the Jetty thread to virtual thread tool thing, what we can do for you is the following, is that we turn on something because that's now costly, okay? But we can track the virtual threads for you. And so we can say every time we start a virtual thread, we store it away. This guy will store it away. So now if you have your system in this way, you just go to the Jetty facilities and you say to the Jetty server, hey, dump your internal state. And the Jetty server will just dump your internal state, and in that dump, you will see, oh, you have 250 virtual threads that are waiting to enter the JDBC connection pool. And so now you will have a complete, clear picture of what's going on in your system. That it is more difficult to find with the normal tools that you have around. So it comes with a little bit of overhead, but if you're, if you need to troubleshoot system, this is just priceless because you want to deal with the other thing. I'll give you another example. For the same reasons of overhead, because virtual threads are supposed to be super quick and super fast, right? So they do not have a name, a thread name. Why is that? Because in order to have a thread name, you would have to concatenate a prefix name with some kind of dash and then a progressive number in there, right? So you would have to have a string concatenation. So it turns out that the cost of the string concatenation is a cost that you maybe do not want to pay when you allocate a virtual thread. So by default, they have no virtual threads. So now again, even if you go with the normal tools in your system and you say, hey, I want to have a dump of all the virtual threads, now you have 250 threads that have no name, that now you're fine, okay, 1 second, where are, who's allocating this virtual thread? You have no idea. Are the Jetty ones, or someone else is allocating them and I have no idea? Now you have to figure it out by looking at every single stack trace that for every single thread and saying, maybe this is not Jetty, maybe this is Jetty, but you don't know. And so now you have more troubleshooting problems. And we had this problem, so I'm reporting them for interesting, war story that we had to figure out. Okay, quick run on the clients. We have a high-level HTTP client that can support all the multiple HTTP protocols available. So HTTP1, HTTP2, HTTP3, FastCGI, and you can write in custom protocol if it has a semantic similar to HTTP. Okay, so get, resource, headers, and something like that. You can implement your own protocol and you can have it work as if it was an HTTP client. But the other thing that I think only the Jetty project has is that we can now match and mix the protocols with the way they are transported over some transport layer. So for example, HTTP1 or HTTP2 are TCP-based protocol, but it turns out that you can also transport them over Unix domain sockets. So you can configure the client to say, hey, I want to make an HTTP2 request, but not via network, TCP network, but via Unix domain sockets. And so you can do that. Also, we have an implementation for UDP quick and also memory. And so what you can do, for example, quick is the low-level protocol that is below HTTP3. Okay, but quick has the same features as TCP fundamentally, even if it is based on UDP, because quick says, I'm based on UDP, but I'm going to provide you with reliability and ordering, which is the two key features of TCP, right? So at that point, we'll say, wait 1 second, but if Quick can do that, well, why can I not use Quick to transport the TCP normal protocol like HTTP1 and HTTP2? And it turns out that you actually can, and we have done it. So you can now say, well, rather than using TCP, you can use Quick to transport HTTP1. I mean, it's a bit of a stretch, but the real thing here is that no other client will have this flexibility that like you can say, oh, I want to use, for example, we use our current setup for our own website is going to be a Jetty server. Inside the Jetty server, there is a Jetty client that takes the request from the browser, converts it into FastCGI, and then sends it over Unix domain to the PHP server that runs WordPress. And so we can do FastCGI crisscross with Unix domain and have a completely working system that does that. So that's a cool client. It's based on Fluent APIs that are based on events. Again, everything is asynchronous here. So here you can see, for example, you create a new request, you have a path, you can specify the headers, you can have this request begin method, event. So when the request begins means when it's pulled out of the queue and we start sending it over the network. And so this gives you, for example, a difference between the request queued event and request begin event. So now if you have a system and you say, oh, my system is not really performing well and I'm using the Jetty client, how much time am I spending, my requests are spending time queued on the client because they do not have enough resources to go towards the server, right? So maybe you have a need to change your configuration to make it more scalable or to handle more load. And here, for example, you have on response to the bean, which is the moment that we receive the first information from the server, right? And now you can tell the difference, how long did the round trip to the server, processing on the server, round trip to the client, how long did it take? Is the external system that I'm calling that is slow and not my fault? And this is really interesting because now you can really pinpoint and say, hey, I am making a call to that microservice over there. They are slow and it's not my fault, right? So call that department and tell them to be quicker or change the configuration to be quicker. I said before that we also have the low-level implementation of the HTTP2 and HTTP3 clients. So this is really useful if you have to deal with the low-level frames and details of those two protocols. We have a WebSocket client as well that is based on the HTTP client, so it uses the HTTP client to do the initial request, and we also support WebSocket over HTTP2. So before, what was happening was that you would open a single connection to the server, but then if you wanted to speak WebSocket, you had to open a different connection to the server. Now, what we can do is that you open a single connection to the server, you send an HTTP request on one stream using HTTP2, and then you open another stream, and that stream now becomes WebSocket. And then you open another stream that can be also HTTP2, and another that can also be WebSocket, and they can, be there inside a single TCP connection that you have on the server. This is, for example, is very beautiful if you have to speak WebSocket and you have a really big cluster, because now the number of connections that we're going to use to call to all the nodes in the cluster is much less than it was before, because you just open one connection, and in that connection you can speak multiple times WebSocket, multiple times HTTP with just one connection. So future work for Jetty 12 is going to be 12.1.x. It's going to be kind of backward compatible, but we're going to take the chance maybe of polishing up and deprecating things and removing things that are deprecated. We are already in very good shape at implementing Jakarta EE 11, which is due this summer, but we are already running against the TCK that proves that we have a good implementation for that. And then the other work that I hinted before was quick on streams, which is this new way of transported quick, the streams of quick on top of TCP and TLS rather than UDP, so that you can have an easier way to call the backends from other things. And then we have improved the buffer APIs for, improving the APIs of Jetty Core itself. So that's basically it. If you have any more questions, happy to respond. Otherwise, we can stop it here. I don't know if there's someone online asking questions. I'm asking here to my host, I wish.
So thank you, Simone. Thank you so much. I have always been very fascinated by the story of Jetty, and I also know it has been a very important open source project that has been also used in several Norwegian major projects.
Nice.
I have used it myself in some of my projects in different public and private, sector projects. So I'm happy to listen to the story. And I'm also happy that Jetty is now back in the. It has a home and it's maintained by good people. What do you have what would be your best advice for people who haven't maybe updated Jetty for a while? The Norwegian industry has moved. We have been doing microservice architectures for some time now, but what would be your best suggestion for people who want to upgrade and migrate and get up to date with Jetty now?
Do I need to unmute myself, right? Or
Yeah, you can just talk.
talk there. Okay. So the best advice would be the following. If you are on a very, very old Jetty version, let's say 7 or 8 or even 9, I would say that your best option is going to be to jump straight to 12 now and skip entirely 10 and 11 because fundamentally you want to do the conversion just once, right? So if you have still a Java EE 8 application based on javax.servlet, you can take that web application, no problem, that was now running in Jetty 9, let's say, and you just move it to Jetty 12 and you keep it exactly like it is and it will work just fine in Jetty 12. So you don't need to change the application. You just need to upgrade Jetty and then run the application. Of course, you need to do all your testing, verify that everything works as expected and everything, but the effort for the migration is pretty small. If you decide to say, oh, okay, and same goes for, Jakarta EE web application that you have already, that maybe are running in Jetty 10 or Jetty 11. You can just move them to Jetty 12 as is, and they will just work. For new web applications, I would say just code your web application with whatever is your style. For example, if you're using Spring Web Flux, and you write your war file with Spring in it and, coding against the web flux, which eventually goes down into, the Servlet API, that's great too. It's, it will work and you just use the latest version of Spring, which will carry the latest version of Jakarta, which will work in the latest version of Jetty. So that is a normal development path. And then if you need to do like a big migration of many things that were written against older API, say, for example, that we're going to go from JavaX to Jakarta finally, well, then I would recommend, again, the same case would be do the migration first in the code. So convert everything to be Jakarta something rather than JavaX or something, which could be complicated, because it's not only the servlets, it's going to be transaction, it's going to be JDBC, sorry, no, JDBC is part of the JDK, but, it's going to be many other things that are related in Java, or for example, CDI, for example, and JavaX Mail is now Jakarta Mail, all those technologies, you need to convert them, and you have to do it, unfortunately, all of them at the same time. You cannot say, I'm going to just convert the servlets, but I'm going to use the CDI still at JavaX, because they will not match with each other. So you need to do a big effort to convert everything. Once you have converted everything, fundamentally, the fact that you're choosing Jetty 12 will just make your application run seamlessly in that. So if you have a standalone server, for example, it would be completely feasible to say, I'm going to port my old web application JavaX. I don't want to touch it, deploy in Jetty 12. I have a Jakarta web application that works, deploy in Jetty 12. It's fine alongside the other one. If you want to use multiple instances of Jetty, that's fine too. If you want one instance per web application, depending on your requirements, that works fine too. The key point is that at a certain point, you're going to have just one version of Jetty that you're going to manage, right? And so that is a big plus, because now you say, hey, let's standardize our infrastructure to use Jetty 12.0.10, for example, and then we just go from there. And like when 11 is going to be out, we're going to, start a process inside the company to upgrade to Jetty 12.0.11. Let's see if everything works. If there is no problems, we run all the CI integration, whatever you have. And then you say, okay, now we can upgrade Jetty and it's cool. Rather than having to say, oh, no, we have this old application that needs the Jetty 9. but then this other one that needs Jetty 10, but also this one that needs Jetty 11, and now suddenly you have 3 different versions of the same server fundamentally, but you need to keep up to date with each one of them, and it's more complicated. With Jetty 12, you can just say, well, let's go Jetty 12, and the only blockage for that would be that if you're not willing to upgrade to Java 17, which is the minimum requirement for Jetty 12. But nowadays with Java 20 out, 21 out, I mean, 17 is becoming the old long-term support release now. And, you know, 22 is already out. 23 is going to come in September. And when it comes in September 25, which is going to be the next long-term support release, is just 1 year away. And 1 year just passes like nothing. So, you know, suddenly you have people starting to say, oh, we don't support anymore Java 17 or something. And so now if you're still on Java 8, and now you're going to panicking because you're still in Java 8, you're not on Java 17, now there's 25, and you're so behind that it's going to be like a big problem. So yeah, don't do that. Just move to 12, Jetty 12, Java 17, and it's going to be like I would say a smooth transition, just because we support everything. And then if you have a problem, there's a company behind it that can help you out in a much faster way than you trying to figure out things, right? You don't, if there is a bug in the JDK, you don't put your engineers to trying to solve the bug in the JDK. You just call Oracle and say, hey, we have this problem. Can you please help us? If there is a bug in the Linux kernel, you don't put your engineers to fix the bug in the Linux kernel, right? You just go to Red Hat, whatever is supplying you with the Linux kernel, and say, hey, help me out. And the same goes with Jetty. Don't put your engineers to trying to solve a Jetty problem, or, you know, a Jetty, or possibly a Jetty bug, or maybe something that we have seen 20 times already, and we can just tell you in like 1 minute, oh, just change this configuration to be that done, right? And then all your engineers can just do some other work, and you know, you're gonna save money by, you know, having a normal support contract like you do for everything else. It's like you have support contract for Oracle, Red Hat, and all the layers up. So, you know, it's good to have one for us.
Luckily, I know the Norwegian community has made significant moves towards the newer versions of Java and the newer versions of JVM. So I clearly see that it will be easier to actually migrate and upgrade. There is a question from the community.
Sure.
What advantages do you see using Jetty contra Tomcat with Spring Boot?
So one of the advantages is the one that I've been speaking right now. There are multiple versions of Tomcat for every different Jakarta EE one. And because at a certain point, the Jakarta EE 10 has become incompatible with the previous one, you cannot anymore say, oh, I have a very old web application. You deploy it in the latest Tomcat version, it might or might not work. Unfortunately, you will discover this at runtime. If it works, great. You just stay on the latest version of Tomcat and it's great. If it does not work, now you have this problem that you have to keep an old Tomcat around for the old application and a new Tomcat around for the new applications. Regarding the performance or features or everything, I cannot speak that much. I mean, we normally don't do this kind of, well, at least I'm the not the right person to ask for comparisons with Tomcat. First of all, because I don't really know it very well. I'm assuming that if you stay within the bounds of the server specification, they are absolutely compatible. If you stay on the bounds of, okay, but now I need to do some container-specific configuration, for example, support for virtual threads or things like that, or, you know, scalability issues, or can I have a feature, for example, we have a feature in Jetty where you can have a configuration that says, hey, if you receive too many connections from outbounds, what we're going to do is we stop accepting connections. We keep the ones that we have, but we stop accepting connection until such time you tell me you're fine and we can accept connections anymore. So this is done at the very low level, IO level, right? I don't know if Tomcat has this feature, but this feature, for example, saved many of our clients that had a spike of requests from multiple different clients. Imagine, for example, you are a newspaper, okay? A big earthquake or some kind of big events happens. Everybody's connecting to your website to find information, right? So you have a lot of new connections to that. So what are your chances that your website is going to go down like it happened in the past for many? CNN went down when the 9/11 event happened. And so this is one of the features that we have in Jetty. Maybe it is in Tomcat too, but I don't know. But yeah, we have, for example, one of the nicest features that we have that we use all the times is the fact that we have an internal state for the Jetty server that you can dump at any time. And this is really useful because many people, for example, have problems. They say, oh, my web application is stuck. It's a Jetty problem. And then we ask them, hey, just go to the Jetty server, go there, exactly there, click the button, dump, you get a big string, take the string, give it to us. And then we look at the string and then it says over there, for example, oh, look at that. You have a thread pool configured with 4 threads, and all 4 of them are blocked waiting on a JDBC connection pool. And so you can tell at that point, you don't guess anymore. Like you can tell these guys and say, hey, look, your thread pool is really small. Why did you configure this small? And they tell you, oh, but because we have 4 cores only. Well, that's great, but 4 threads and 4 cores don't always go hand to hand. I mean, it's fine if you only do CPU intensive work, but the moment you do a little bit of IO, for example, calling a database, well, then one CPU becomes free because it's now waiting for the database to reply. So that CPU is now doing nothing. So at that point, you can have a 5th thread. So one thread is blocked there waiting for the database, right? But the CPU is not in use. So you can have a 5th thread that actually goes into that CPU and does some work. So you can configure the thread pool differently and do things. So we have this. This is really useful. I don't know if Tomcat has it, but we are trying to be really friendly, especially with the troubleshooting and all the features that we have. We try to keep our documentation as up to date as we can with all these features. There's a ton of them, and it's always sometimes really daunting to document them all, but we try.
I mean, one last thing here is that in the Norwegian community, especially probably the public sector, there has, in the last maybe 4 or 5 years, there has been a major move towards Kotlin.
Okay.
And Ktor has been something that is being more and more used. I mean, in addition to Spring Boot and Ktor, there is a lot of use of. I checked, and I saw it's possible to configure Ktor to be running with HTTP2 with Jetty.
Oh, okay.
Do you have any? Have you been looking at the integration with Ktor and Kotlin and so on?
Not me personally. I know that this has been done. As I said before, there was one issue that was filed against Jetty because they were using Kotlin as a language to use Jetty. I know Javelin, for example, is a project based on Kotlin as well. They uses Jetty inside. But fundamentally, we're kind of Switzerland in this case, in the sense that if we can offer a Java API, typically this Java API works from Kotlin too. And in that case, at that point, if we have Kotlin users that are happy with Jetty, we're happy too. So, and if we can, if they come to us and say, hey, if you do this, it will help more us because it will be more Kotlin-like in a way if you do the API in this way, etc. We'll certainly take a look at the suggestion, and why not? It's in our interest to actually be friendly with the Kotlin community, and it's interesting. For example, we used the JetBrains products, IntelliJ in particular, to develop Jetty, and it turns out that Jetty is the server that is inside IntelliJ in order to present like HTML stuff and I think the documentation and everything. So it's it's a wheel that spins, and we're happy to help with the integration from many projects. So it's if it works in Ktor, great. It's a good thing for us, and it's a good thing for the community. So we're really happy. So
yeah. Any questions from the room?
No.
I mean, for the future, I think you mentioned some future work on Jetty. I was also thinking about the times we are living in with the artificial intelligence moving in all over the society, and the amounts of data is massively increased and so on. Any thoughts about where Jetty would belong in that big picture?
So we had a few discussions about this, and there's two layers to this. One is the implementation of the server itself, and that is unfortunately a little currently, because I have to say that, I mean, in 6 months the AI could be way beyond what we're doing, but currently the specific implementation of a complex web server that should be also very efficient is beyond what an AI can suggest us. We use the AI during the development, for example, in the IDE, right? So for things that are typically simpler. But for example, taking API design decisions, or is this better than that? These are things that you have to measure and try and basically gather together a bunch of people with good experience and say pros and cons of this decision, and let's see where we're going. So AI cannot really help us unless auto-completing the line of code that we're writing right now. But then for the whole picture is really difficult. On top of that, so web applications that actually use AI, well, then that is, yes, an absolute yes. But that is fundamentally somehow detached from Jetty, in the sense that Jetty is below, it is the engine that runs this. And if you put a web application inside that uses AI, that's great. But fundamentally for us, it's transparent, right? We just call you, and we just, you do your thing and we do our thing. Internally, however, I think it's going to be, for now at least, difficult for that. For example, solving hard concurrency issues that are created by the API or even the protocols, right? There are cases where the HTTP protocols can stop a request at any moment in time. And when you receive that event from the client, you have to decide, okay, how am I going to handle this? Because maybe I am just in the middle of something that is going on right now in the application code. Am I calling them and telling them, and am I interrupting the thread? What am I doing? And that requires some kind of experience, human experience of, I've written a server like 3-4 times already. I know that this didn't work in the past. I know that this other solution was too complicated. And so the best of all the worlds would have been the solution, this other solution, right? And so I don't think an AI could have still that wisdom yet. We'll see in the future what happens, but it's going to be interesting times. I mean, 6 months ago, we could not believe what an AI could do now. So, and if you go back 1 year, you wouldn't even imagine what an AI could do now. So I don't know, give it 5 years, and I now cannot imagine what an AI could do in 5 years from now. Maybe it can just rewrite Jetty from scratch 20 times better and faster than what we're doing. And if so, well, Okay, well, we'll see. We'll work on other things that maybe it cannot do yet. Try to improve on top.
Yeah.
We'll see.
Great. Thank you so much
No problem. Thank you for
being
hosting
here.
me. It's been really great.
And enjoy your time and
Thank you.
vacation in Oslo. And thank you for everyone who has been watching. If you have any questions about javaBin, please look at java.no and send us questions if you have questions about our community. My name is Dervish, and thank you so much, and have a good evening.